So please join me in welcoming the distinguished speakers of both the panels. May I invite on the stage Mr. Ganesh Shankar Mishra, Managing Director, Madhya Pradesh Kshetra Vidyut Vitaran Nigam. Let me also invite Bhaskar Sarkar, Chief Executive Officer, Tata Power Northern Odisha Distribution Company Limited. Welcome, Bhaskar. Dr. Tripta Thakur, Director General, National Power Training Institute, NPTI, National Power Training Institute. Let me find if Girish Murle is there. Girish Murle from, Software and Solutions Siemens Limited. Welcome, Girish. He is a General Manager in Siemens. This was the Discom side of this panel. And from the Transcom side, please join me in welcoming our program chair, the man who is behind the entire show today, Mr. Dinesh Wagmare, Chairman and MD, Maharashtra State Electricity Transmission Company. But for his cooperation, his support, his mentorship and guidance, this fantastic conference would not have been possible today. A very warm welcome to Mr. Dinesh Wagmare. Let me also invite Mr. K.K. Verma from Jharkhand. He is Managing Director, Jharkhand Urja Vidyut Vitaran, Jharkhand Urja Sancharan, Jharkhand Transcom to be summarizing. After Jharkhand, we move to Telangana. T. Jagat Reddy, Director Transmission, Transmission Corporation of Telangana Limited, TS Transco. From the industry side, we have the MD of, I don't think he's there, Syed Salahuddin. From the industry, we'll be having Chief Executive of Ramalex Group, Shubhas Kelkar. Shubhas is there? To ask him to join the stage. Very warm welcome, Shubhaji. So I leave this dais under the guidance of Mr. Wagmare, and hand mics, please. Wagmare sir would be giving a small presentation on transmission opportunities, the role of technology in transforming the transmission sector in his organization. Plus, I would also request sir to please conduct this session, and as well as Dr. Tripta Thakur. She's an academic. She's the DG of NPTI, and she's from NIT Bhopal otherwise on deputation to NPTI. She can also share her wisdom on this panel. A combined panel of distribution transmission. Over to you, sir.
Good afternoon to all the delegates, and welcome to the panel members. Actually, two panel discussion has been combined together. The first panel is panel discussion 2, Discoms turnaround through technology leverage, enhancing billing and collection efficiencies, smart meters, smart grid, regulatory reforms, and public-private partnership opportunities, and viability gap funding. So from this panel, Mr. Ganesh Shankar Mishra, Managing Director, Madhya Pradesh Madhya Kshetra Vidyut Vitaran Company Limited is present. Mr. Bhaskar Sarkar, Chief Executive Officer, Tata Power Northern Odisha Distribution Limited. Dr. Tripta Thakur Madam, Director General, National Power Training Institute. And Mr. Girish Murle, General Manager, Software and Solutions, Siemens Limited. There was another panel, actually it was on energy transmission, emerging technologies for driving operational efficiencies. And I was actually part of that panel. And along with me, Mr. K.K. Verma, Managing Director, Jharkhand Urja Sanchar Nigam Limited is there. Mr. T. Jagat Reddy, Director Transmission Corporation of Telangana Limited. And Mr. Subhash Kelkar, CEO, Ramalex Group. So actually, I welcome all the panel members. Since actually, initially the topic given to me was energy transmission, emerging technologies for driving operational efficiency. So my presentation is basically on transmission side. Indian transmission network is one of the largest single national grid in the world, spread over 4.5 lakh circuit kilometer transmission line and about 11 lakh MVA transformation capacity operating at one frequency. At Maharashtra, like Maharashtra State Electricity Transmission Company has actually around 50,000 circuit kilometer of transmission, a substantial share in Maharashtra. And our MVA transformation capacity is around 1.5 lakh MVA. India has set a target of increasing non-fossil fuel generation up to 500 gigawatt by 2030, with great emphasis on wind and solar generation. And this basically put a lot of challenges for the transmission sector, and grid integration also has become major challenges. There are many challenges in implementation of transmission system, especially acquiring land for establishing a pooling station or substation due to rapid urbanization. Right-of-way issue and availability of skilled manpower for construction of new line and age-old asset is one of the challenge. Right-of-way is actually to the heart of transmission utilities, and nowadays actually getting right-of-way for the transmission lines has become increasingly difficult. In fact, there was a policy of government of Maharashtra for transmission tower. We used to pay double the ready reckoner rate, and for transmission line, we used to pay 15% of ready reckoner rate, and that too only for the wire corridor. And basically, we are facing a lot of issues in Mumbai metropolitan region areas and most of the urbanized area. So where actually there is a huge difference between ready reckoner rate and actual market rate. And sometimes that difference in Mumbai area going up to 7 to 8 times, even going up to 10 times. So that actually becomes major challenge. So in fact, now we have revised the policy, and now actually it is a ready reckoner rate or sale transaction for the past 3 years, average of those sale transaction, whichever is higher. And we are giving double the compensation for transmission tower. And for instead of taking wire corridor, now we are taking line corridor. And basically, the compensation is increased by 15% more. So it is actually 15% plus 15%, 30% of line corridor. So effectively, it will be 60% of 60% of wire corridor. So hopefully, actually, this will resolve most of the ROW issues. And basically, because of a lot of ROW constraint, in fact, modernization and modern technology of existing transmission infrastructure and maximum use of existing transport capacity is very much essential. And renewable energy basically demands a lot of actually augmentation in transmission capacity. Government of India is planning to modernize the transmission sector and make it future ready. MSCTCL has adopted innovative and advanced technologies for the transmission network. It is in continuous process of upgrading its technology with time. Main areas of application of different emerging technologies are modernization of existing transmission infrastructure, use of advanced technology in O&M, smart and future-ready transmission system. One of the major actually modernization measure is reconductoring and voltage upgradation of existing line. So instead of ACSR conductor, now actually in MSCTCL we are using high temperature low sag conductor. And by using high temperature low sag conductor, basically the transmission capacity actually increase by 1.8 to 2 times, because this high tension low sag mainly like triple C carbon core conductor we are using, and because of that actually there is a low sag, and more power can be, and ampacity of the conductor gets increased, and in effect we are able to transmit more power. So wherever the line loading is much higher and there is critical constraint on the transmission line, we are using HTLS conductor instead of ACSR conductor. Then use of insulated cross arm. This is very actually existing transmission corridor can be used, and if you use insulated cross arm, it helps to upgrade the line voltage while retaining the existing tower and foundation with few modification to enhance the capacity of existing transmission corridor by about 2.5 to 3 times in quick time. So actually, if you have ROW corridor and if you have 132 kV lines, you can easily actually upgrade to 220 kV level, and it is very low hanging fruit. So actually, if you use insulated cross arm, so you can enhance the capacity of transmission line. The line voltage can be increased. Third is dynamic line loading. Dynamic line loading is an overhead transmission line real-time power flow monitoring system. Dynamic line loading sensors are becoming popular globally with the utilities for enhancing effective line capacity. DLL, once installed on the line conductor, provides real-time situational awareness of conductor temperature, sag, current, and weather condition. So depending upon weather condition, depending upon wind condition and temperature and sag, basically, you can determine how much power can be transmitted to the transmission line. Additionally, it provides predictive loading level to effectively enhance the line capacity under favorable weather condition. Depending upon the weather, transmission line capacity can be enhanced by about 15 to 20%, and reliability can be increased by using DLR devices across the line without violating the operating temperature and sag limits. Battery storage as transmission grid element. So in fact, we have not yet so far used that. So there is a lot of use of battery storage in distribution system. In transmission system also, battery energy storage system can be a great transmission asset. And basically, it will help especially for evacuation of renewable capacity in quick time. And these actually battery energy storage system will also be useful whenever there is a grid failure, and the black start operation will be very much easier with the help of battery energy storage system. In fact, we have in Maharashtra a lot of transmission utilities. We have private transmission utilities also. So in fact, like Adani Electricity and Tata and MSCTCL, so all up have prepared proposal for installing battery energy storage system as a transmission asset in Maharashtra grid. Use of power flow controller for reactive power compensation. So reactive power actually is reactive power compensation is very much important for reliability and stability of grid. So wherever there is a load which actually generates a lot of reactive power like motors, and so in fact you need a lot of reactive power compensation in the grid. Existing transmission line load ability can be enhanced with the use of power flow controller like series capacitor, static synchronous series capacitor, voltage source converter by about 30% depending upon the degree of line compensation. Besides, this also helps to control uneven loading in parallel corridors in meshed network. Centralized remote monitoring and operation of substation. So this is actually a new thing coming up, and I'm glad to share that MSCTCL is one of the first state transmission utility. So we have actually set up Maharashtra State Asset Management Center in Navi Mumbai, where the remote monitoring and control of switch gear, bay equipment, data acquisition, disturbance record and event log, ID configuration and parameterization, asset management, video surveillance, etc. Basically can be done. Initially, the project is taken for only 22 number of substations, and we have total 701 substation, but initially we have taken 400 kV critical substations. So in fact, when this will be fully operationalized, so most of the operations can be done through remote monitoring. In fact, Power Grid Corporation actually is a central PSU in transmission. So they do most of their operations, and their asset management center is located in Gurgaon, Delhi. Other use of advanced diagnostic tool for conditioning monitoring of substation equipment, predictive maintenance using digitalization and using artificial intelligence and machine learning algorithm. So artificial intelligence actually is very much useful, but then use in EHV network is very much limited. But then we should definitely use artificial intelligence technology. We are using remote drones cameras for actually surveillance of our transmission tower. Earlier we used to do manual patrolling, but now we have switched to drone-based patrolling for our 400 kV towers. Use of incident response system for efficient management of disaster or crisis situation. This already I have actually told, like we are using drones. In fact, it's basically unmanned aerial vehicle where actually payloads are like thermal scanning cameras and other devices are payloads, where actually instead earlier our technician used to climb on the tower and do all the diagnostic. So now it is done using drone. So and the images are basically are uploaded on the cloud. And on cloud, our engineers, our capacity has been developed so that our engineers actually see those images on the cloud and they do all the diagnostic and then take corrective measures. Then advanced diagnostic tool for condition monitoring of substation equipment. And this is important to detect defects in substation equipment of incipient stage using advanced diagnostic tool for equipment condition monitoring such as SFRA, C and TAN delta and other diagnostics. Use of incident response system I have already covered. Then smart and future ready transmission system is need of the hour, and with the more dynamics in transmission network, so in fact this grid has to be smart, and in fact it should be able to cover the dynamics of renewable energy integration. Flexibility through combination of AC, HVDC and FAC devices. So that is also one of the technology. Wide area measurement system using phasor measurement unit at each 132 kV, 220 kV substation integrated with OPGW communication network up to SLDC is essential for real-time monitoring and control of intrastate transmission facilities with reliability and stability. Actually, for reliable control of the grid, visibility is very much important. Presently, we have 400 kV lines, almost 100% visibility is there. And for 220 kV lines, our visibility is 40%. But then for 132 kV lines and below that, our visibility is not there. So in fact, this visibility to actually load dispatch center through SCADA is very much important for reliable control of the grid. So we are actually we are in the process of installing our own communication hubs so that our visibility will be improved. And in fact, we want to have more redundancy so that visibility will not be affected. And in fact, the data which comes to SCADA has actually time lag of, I think it is 50 millisecond or so. But then if you use phasor measurement unit, then actually the data, the time lag is only 2 to 3 millisecond. So actually phasor measurement unit is very much important. So it actually detects the deviation or detects the fault very quickly. So wide area measurement system using phasor measurement unit is much important. We have already installed some phasor measurement unit, but they are not much. Like we have installed around 15 to 20 phasor measurement unit, but we need to install more phasor measurement unit in future. Then cyber security in transmission is also very much important, and in fact there had been attack, malware attack, Trojan attack on our system in the past, and we were able to actually defend our system. And basically IT-OT air gap has to be maintained. And there are different cyber security measures given by Ministry of Power. Ministry of Power has given different guidelines like creation of cyber security information officer, and then cyber security management system, and cyber disaster management system. So actually, we are following Ministry of Power guidelines for cyber security. Capacity building and upskilling of manpower is also important. So if these new technologies come, so our manpower should be basically capable, and we should have increase the skill level of the manpower. Some of the national institute like National Power Training Madam is there, so they are helping us in actually certification for the cyber security, and also we are tying up with other institute like Power Grid Corporation and other important institute to upskill our manpower. So that is about basically how technology can be used for better operational efficiency in transmission network. Thank you very much.
Thank you very much, sir, for giving the insight what is happening under your able guidance in the Maharashtra State Electricity Transmission Company Limited. To carry on the discussion in the transmission only, I would like to invite now K.K. Vermaji, who is the Managing Director, Jharkhand Urja Sanchar Nigam Limited, to share his experience and what the Jharkhand is doing to make the energy transmission with the latest happenings.
In Jharkhand at present, we are facing challenge to evacuate 3000 megawatt power in the year 2024, especially thermal power likely to be generated by Patratu Vidyut Utpadan Nigam, a JV of NTPC and JVVNL, Government of Jharkhand, and 600 megawatt power of North Kanpura, which has been put under commercial operation by NTPC. As sir has rightly said, problem of right of way, non-availability of skilled manpower in this field, and the third major hurdle of getting forest clearance. When we award a tender with a completion period of say 2 to 3 years, on an average in the country, for getting forest clearance, it took not less than 3 to 4 years when I studied in n number of discoms, in n number of energy utilities. And same situation lies with whatsoever problem we are facing with right of way. Maharashtra is glaring example to be followed by our state regarding payment of compensation. I will share and implement because we are facing a number of right of way problems. Extensive utilization of monopoles and rather much diversified with a stronger tensile and mechanical strength of designing of poles, structures which takes less power and transmit high power for a efficient making corridor in forest area is the much demand at present needed in our state. For new construction of transmission lines, my state is facing a number of problems, and we are resolving it with the tools of modern technology which are being employed in this field. We are going to employ extensive use of drones for emphasize to right of way for laying transmission lines and for construction of transmission lines also in coming future. In transmission, in smaller states like us, where 132 kV and 220 kV lines are of very old type, there is always breakdown and other things which requires modernization with latest tools. So there is huge scope in the field of transmission in coming days. Sir has rightly said, extensive use of artificial intelligence, machine learning, and SCADA, and like that, we may do a lot in this field. So on the whole, we have to share the latest developments made in regards with the construction of new transmission lines, operation of high value transmission lines, and dilute TBCB concept, tariff-based competitive bidding concept, just to provide liquidity of fund in construction of transmission lines. Recently, what problem we have faced from regulator side in implementing TBCB-based transmission lines? Because always states like ours, Jharkhand, are facing with financial crunch. In infrastructure, construction of new transmission lines comes under the head infrastructure. But even when we approached NABARD, they refused to grant us soft loan. It is very difficult to have a loan of say 11.5% for construction of new transmission lines for evacuation of 3,000 to 4,000 megapower in Jharkhand state. So the only way left out for a state like us is TBCB concept, tariff-based competitive bidding concept. But there are only two companies, Sterlite and one more company, Adani. There is need of rather n number of companies, say 6 to 8 companies in the country, so that the state like us may think over it for construction of new high value transmission lines, 400 kV or 765 kVA. That is much demand of time. This is all my view for my transmission scenario in my state. Thank you.
Thank you so much, Verma-ji, because you represent Jharkhand, which is very unique, rich in heritage as well as in the forest. But we can understand the difficulty, and I hope the government will look after the special provisions for Jharkhand in future. Now, I would like to invite Jagat Reddy ji for sharing his experience for the transmission, as he represents Transmission Corporation of Telangana Limited. As the time is very limited, I request you to please bind up within 5 minutes, sir. Yes. Thank you.
Respected dignitaries on the dais and dear friends of the dais, Telangana Transmission Corporation. Telangana state has formed in 2014 June At the point of time we had, I just run through, we have added the generation capacity from 7,000 to 17,000 and solar capacity from 74 megawatts to 5,100 megawatts. Here I want to say the entire solar generation is commissioned at load side. Telangana state has not built a single transmission line, not added any transformation capacity for achieving this 5,000 megawatt solar generation. The peak demand has increased from 5,600 megawatts to 14,000 megawatts, and of course we have constructed the consumption also from 128 million units to 283 million units per day peak demand. We have constructed about 17 numbers of 400 kV substations in last 8 years, and 220 kV also around 48 substations and 74 numbers of 132 kV substations. We have built about 6,000 kilometers of 400 kV transmission line within a span of 8 years. Hitherto it was only some 1600 circuit kilometers in 2014. Now it is 7,800 numbers, 7,600 or 800 circuit kilometers we have built. And of course, the total transformation capacity also has been added, about double the capacity, transformation capacity. In addition to the lift irrigation capacity, transformation capacity is about 10,000 MEA capacity, lift irrigation capacity, and from 14,000 to 27,000 MEA transformation capacity has been added into the system. This is the grid map, 400 kV grid map. Around Hyderabad, we have a 400 kV ring, and about 70 to 100 kilometers away from Hyderabad, we have another 400 kV ring, and around 200 to 250 kilometers of the Hyderabad city, from Hyderabad city, we have another ring. All these 400 kV rings are connected to generating stations and interstate transmission lines and the lift irrigation substations of the state. This is going to give the most reliable power supply to the state, and this is the ring around Hyderabad, 400 kV ring with 7 numbers of 400 kV substations and 220 kV ring and many more rings of 220 kV all over the places. The capacity, transformation capacity addition year by year, it is given. This may not be required very much. Transformation capacity addition. And this is the load increase, load pattern increase. Within a span of 7 years, the load pattern increase in each district of Telangana is varying very high due to industrial growth. And this is the generation capacity, solar generation capacity, another 1,800 megawatts we are going to add by 2024. All this generation addition is at the load end only. We are not going to build a single transmission line. We are not going to add any transformation capacity in the city. This has been spread over, generation is spread over all over the state, and we have given a facility, ring means ceiling facility, ceiling capacity. Each substation solar addition must not be more than 50% of its transformation capacity, and district capacity also, district capping also has been provided. The solar generation has been added all over the places, all over the state, and this is our per capita consumption of Telangana state. National average is 1200 units, and whereas Telangana state is 2071 units per capita consumption, improved from 1356 to 2071. And the transmission losses has been reduced from 4%, around 4% to 2.42%. This is because of the 400 kV network that we have constructed and the solar generation added at load end side. Of course, this is the transmission system availability. We are continuously maintaining the transmission system availability all over the 5-6 years. during 2015 March Assembly session, our Honorable Chief Minister has declared the daytime 9 hours agriculture supply to the agriculture consumer, all the agriculture consumers. So he has given a mandate for improving the transmission line and transmission system capacity. We have added 5,300 MEA capacity at 132 by 33 kV level and 2,750 MEA capacity at 220 by 132 kV level and 1,000 MEA capacity at 400 by 220 kV level within a span of 11 months by adding 144 numbers of new transformers into the system, and shifting another 95 transformers from one place to other place. All this has been done within a span of 11 months, and the 9 hours daytime agriculture supply is given to all the consumers from 1/4/2016 onwards. Of course, number of lift irrigation substations has been constructed. The MEA capacity is around 7,000 MEA. This is Kaleshwaram lift irrigation project. These are all the ongoing lift irrigation projects that Telangana Transmission Corporation is constructing. These are all the future lift irrigation projects that are going to be taken up by Telangana state. Yeah. As Mr. Wagmare sir said, that we are also going with HTLS conductor, and we have done about 10 numbers of 132 kV lines because of augmentation of transformation capacity for 9 hours daytime agriculture supply. And of course, we have done it in 3 lines, 138 kilometers, circuit kilometers of 220 kV line within a span of 3 months. 3 months. Zebra conductor has replaced with drake conductor, HTLS drake conductor, and the transmission capacity has been added within a span of 6 months. Total Hyderabad city was in trouble at that point of time. So by changing the conductor, we have done it in 3 months. All the 138 kilometers work has been done within a span of 3 months. And in live condition, keeping one circuit in live condition, all this has been done. And of course, we have got the PSD funding grant also for this. Lot of saving if you use the HTLS conductor. The country has got an installed capacity of 406 gigawatts generation capacity. The planning is 750 megawatts, 750 gigawatts generation has to be added. Around 350 gigawatts has to be added within a span of another 7 years. So how much transmission capacity we have to build in the country? Almost you have to double the transmission capacity within a span of 6 years. What has been built for the last 70 years, 78 years, 75 years, you have to do this transmission network capacity addition. So you have to use all the technologies that are available in the country or all over the world. HTLS is the best technology, means conductor changing. You cannot add everything in a new line, through a new line. Wherever it is possible, capacitation is required, we can change the conductor and we can get the work completed, work done within a very short period. Within a very short period, we can do it. So, in building up when transmission network is being planned, all different types of planning has to be discussed, and then only the new transmission line proposal has to be made. We being in Telangana state, we are doing that, and the 220 kV transmission line is loaded up to 400, single circuit has been loaded up to 495 megawatts. When it is the first day when we have charged that line, we went up to 495 megawatts loading, and we tested it for half an hour, and then the load has been reduced. Even in 132 kV line with Casablanca conductor, we loaded the lines up to 192 megawatts, single circuit, 192 megawatts, and we kept it for 5 days continuously. It is a proven technology. For capacity addition, transmission capacity addition, I think that is going to be a boon in the country in years to come. Of course, we are using all types of GIS equipment in our substations. We have fast models, we have outdoor GIS substations, we have indoor GIS substations. Very recently, we have constructed a 400 by 220 by 132 by 33 kV GIS substation in heart of the city, Hyderabad, heart of the city, Raidurg IT area. We constructed a 42 kilometers of 400 kV line, about 29 kilometers of transmission line over lead structures and 11 kilometers on monopoles along outer ring road and 3 kilometers of cable. And four voltage ranges, means 4. We are giving supply, we have circuits connectivity at 220 kV level, we have connectivity at 132 kV level, and 18 feeders of 30 kV. Provision has been made, and the capacity of the substation is 2000 megawatts at 400 by 220 kV level, and 480 megawatts at 220 by 132 kV level, and 240 megawatts at 132 by 33 kV level. See, this has been all been done in 5 acres of land, only 5 acres of land. Yeah, of course. As I said, we are using all type of technologies. This is the line that is going to the latest GIS substation, means 400 kV GIS substation, Raidurg. It is 4 voltage ranges. This is the substation photographs. Of course, as Wagner said, Telangana state, means the combined Andhra Pradesh state, has converted the 66 kV line to 132 kV line about 30 years back with insulated cross arms, means porcelain insulated cross arms. Recently, we have commissioned 2 or 3 towers with insulated cross arms, whereas the corridor height, means ground clearance, increased by 2 meters and horizontal clearance reduced from 7 meters to 2 meters. With this technology application, we are going to convert 2 numbers of 132 kV lines to 220 kV and reconducting with the HTLS conductor to increase the capacity, transformation capacity, and as well as the transmission capacity. Of course, outdoor GIS also we have gone for, and we have the WebGIS system. As Maharashtra also has got WebGIS system. Total our network is mapped, all our towers are mapped, and we have an excellent construction wing, and with the help of government is totally involved. See, we are, I think, like other people getting the right of way problems, we have very less few right of the problems because the government, Honorable Chief Minister, and our Chairman, Mr. Prabhakar Rao, is all the way, every line, every day, more or less, every day important lines, they are looking at, they are progressing it. Chief Minister speaks to our Chairman 3 to 4 times a day on power sector, power issues. So that's why Telangana state has built up such a big network over a period of 8 years. Thank you.
Thank you so much, Mr. Reddy. It's very informative session. I can recall that when reforms was introduced, Telangana was not separate from Andhra Pradesh, and how Andhra Pradesh took the initiative for implementing reform. Thank you so much. In the last speaker in this session is Mr. Subhash Kelkar, CEO, Ramlex Group. So I invite you to share your experience. Sir, as we all are standing between lunch and so, yeah, please. You want it?
First of all, thank you very much for giving us opportunity to share our experience. Basically, we are talking about the operational efficiency in the transmission sectors. As you know, because the transmissions is comprising of the substation and the transmission lines, and particularly in the transmission substation connectors, you just think about the how many connectors are there, hardwares are there, which is already under the stress over the load condition, various load conditions, and the environmental. Our journey starts with the, Ramal is almost, we have association with the utility and in the almost more than 25 years. To address this particular the connector, we have just in the manufacturing of the connectors. Previously, most of the substations having the bolted type conductors. Now, we have manufactured the compression type conductors. And what we have observed that particularly the resistance when we are using the compression type conductors, the compression type hardware connectors, then the resistance of the effective resistance is reduced. It means the losses in the particularly, it will address the reduction in the losses. Even we have replaced most of the substations, we have replaced with the compression type connectors. And we are now, particularly as you said, because now because of the requirement of the high loading and something, we are using now we are using the STLS conductor because of the limitations of the, we cannot extend the existing transmission lines, and so because of the space constraints or there, we are developed even STLS conductor. Now we are developed STLS conductors and we are supplying STLS conductors also, STLS hardware. Recently, we have observed that particularly the snapping of conductors at the dead end points. There was an issue we have started in 2015. There was some concern by when we are using the triple AC conductors. There was a lot of snappings in the dead ends. Now just imagine, because crossing, just imagine the crossing, railway crossing, highway crossing, river crossing. When it happens, how it affect to the systems. So what we have developed one, that gadget that we call as a sever assembly gadget. It will address the snapping of conductors. By utilizing this particular gadget, the dead end where the failure of the dead end is there, what this assembly is doing, what is benefit of this assembly is that, okay, it will avoid the snapping of conductors. Whenever there is a, let us say, because of the weakening of hardware, it will protect snapping of, it will hold the structures with that assembly, as well as it will maintain the continuity of supply also. That is a very great advantage. So this is, we have just, after having a vigorous R&D we have developed in the 2016s. Then for single conductor, then right now we are doing a twin conductors, we are supplying to the utility also. And recently, we have just participated in the CIA Industrial Innovation Award. And there they have selected almost 50 companies. In that 50 companies, we are one of them. This is talking about the hardwares. In addition with that, particularly we are just doing in the diagnosis services also. Right, substation as well as line. For example, thermography, then coronography, then even PID, when the tower footing resistance. Because in transmission sectors also, transmission lines also, there are insulators. There we are doing even silicon coating, RTU coating, which increase the insulation level so that the failure of the insulators will be less. That's all. Thank you very much.
Thank you, sir. Thank you. We all know that with the support of industry, we can really improve our sector. So we are moving from the mature transmission sector to the unmatured distribution sector. And as all of us understand how important is distribution sector, because money flows back through distribution to other segment. So financial viability of distribution sector is very, very important. So I am requesting Ganesh Shankar Mishra ji, who is Managing Director, Madhya Pradesh MP Madhya Kshetra Vidyut Vitran Company. Sir, as we all know that lot of reforms are put up by the central government in the form of RDSS. What do you feel about this and how, because electricity is a different kind of a entity, so what kind of business requirement are there to improve the distribution sector?
Thank you, ma'am, for giving me this opportunity, and I also like to thank ELTS for inviting me here. Uh, for me, distribution sector has its own challenges, and apart from the financial viability part of the discussion, I think time now is ripe for having a rethought about how are we going to create an asset that is going to meet demands of the future generations. And luckily, Government of India has been supporting us through various previous schemes, and just now they have come up with RDSS that is providing us a good opportunity to do something that can augment our system. And our DISCOM as well as our other sister DISCOMs in MP have taken this opportunity to invest heavily in areas that were needing huge augmentation of capacity. But this time we have taken a different kind of stance. We have done a total transformation about how we are going to deal with our projects. We devised an end-to-end computerized mechanism. Earlier, when we used to float our tenders, and then vendors would come, and then they will go on surveys, and then there were so many delays and so many uncertainties. This time we took that part on our head. We did a total GIS survey of each and every asset that is supposed to be constructed. So each and every tower, each and every pole that will be placed is already earmarked on our GIS survey. The estimates have been prepared accurately to the accuracy of last decimal. So we know that what is going to be our expenditure. The vendor management system has been totally made faceless. Nobody will be required for any work to come to our office, or any paperwork is required. Once the projects will be, the work will start, the whole measurement will be done electronically through apps. The quality checks will be done through our integrated quality portal. We have our own in-house enable labs, and all the materials will be sent there seamlessly. So in all, the invoicing is totally paperless. We have tried to come up with an ecosystem where our vendors, when we want to treat them as our partners, and we want to totally transform the kind of interaction that we had with them. And that's how we are trying to increase our capacity dramatically within a very short period of time. So that was one part that I wanted to dwell upon. Secondly, I feel that distribution sector, because of the large consumer base, has it is presenting to us a very good opportunity for data analytics. And with smart meters that are going to come, there'll be huge, immense amount of data that's going to be with us. And if we do not augment our data analytics capacity, there will be sheer wastage of that kind of resource. So we have already started investing in our this analytics parts. We already do. We have a team which does AI and ML, uses those techniques to we have an in-house developed software for checking theft. The vigilance model is there, which uses the data. It tries to analyze the consumption pattern, and that's how we are able to track the outliers. So these are the things that they are presenting us so many opportunities, and I think that in times to come, these will make our DISCOMs. We'll try to get rid of that kind of label that we are not. Commercially viable. We also want to prove that yes, given the opportunity and given the time, we can also be a good commercial entity. And I hope that when we are going to learn from our colleagues from Tata Power also. So there so many things are going on, and I think that state-owned DISCOMs do have a very bright future. Thank you.
Thank you so much. Thank you very much. So, as already pointed out, we have Mr. Bhaskar Sarkar, Chief Executive Officer of Tata Power Northern Odisha Distribution Limited. Sir, as we all know that technologies are going to help us. Like in distribution sector, the major issue is AT&C losses. But in the coming time, how this technology, even IoT, are going to help distribution sector. And as I know in Delhi, your AT&C losses are in the single digits, sir. So how you are doing it and what lesson we must learn from you?
Thank you, ma'am, and I'm happy to be here. And thanks, Elets, for giving this opportunity. As you know, we are a toddler in the block. TPNODL, the Tata Power Northern Odisha Distribution Limited, had started journey 20 months back on 1st of April 2021, and it was a journey for giving transformation, rebirth, and also turning around the distribution company of Odisha. Uh, on the billing side, as rightly mentioned by you, the most important aspect which any distribution company struggles with is the AT&C loss reduction. It has two components: the billing part and the collection part. So I'll briefly touch upon both. When we had inherited this company, the billing part, we found that the figures were good on the apparent side, but when we dug deep into it, we found that the billing, which was having about 80% or plus billing efficiency, actually had 40% of provisional billing, whereby the consumer's existence or the consumer's the billing or consumption being actually reflected into billing was a big question. As also the billing, the meter reading agencies who were there, they used to get indulged in suppressed meter reading, tabletop meter reading. There was no proper process of monitoring and control. And on the collections, so on the billing side, before I go to collection, what we did was we actually have thought through, and we have, first of all, we brought up good billing and collection app or a system, integrated system, which is now in place. It is integrated with our SAP ERP system, which also has been integrated. Then, for billing, we have now taken up a very new and very, artificial intelligence loaded, activity, which is the OCR-based meter reading. So that actually forces the person to visit the meter and take a photograph. The photograph is converted into optical, through the optical character resolution, it is converted. And not only it is converted, OCR is a very common technology where there are a lot of pitfalls, but there is a very profound artificial intelligence built into it. Because the meters are covered with dust, there are a lot of scratches, lot of glares on the meter, on panels, which makes it very difficult to exactly decipher what is the meter reading. So and also the meter reading has to be correct meter reading, the KWH reading. There are a lot of other readings which scroll. So the system has been trained to capture the exact digits, and looking at the curve of the digits, it deciphers whether it is 0 or whether it's a 9. So it's a very very hard coded long tested artificial intelligence which we had tried out in Delhi, and now we have implemented it here. That is giving a very good benefit, because it not only helps to stop suppressed meter reading, it ensures that the meter reader has to go there on the spot to take the meter reading. And also it also ensures that the picture of the meter reading as a proof is coming into the system. So this is going to be a turnaround technology which we feel would be going a long way to correct the meter reading issues. The other thing is that simultaneously, when the meter reading is being taken, the geo coordinates of the meter is also being captured. It helps in two ways. One is that it gets into the server, and through the geo position coordinates, we can decipher wherever there are areas, because this company has very huge areas. And we have now started developing heat maps. And the heat maps gets populated, and we can know that against this geo map there is a red area which is very high areas. This is a green area. This is a yellow area. So we can very very nicely prioritize where to focus upon to collect areas, to take actions of disconnection and other activities. The other thing is that when we thought of this meter reading, the most important part is also metering. And in metering, as we now know that due to the RDSS, all are in the framework of smart metering. So we actually gave a very different look into it. That is smart metering one size fits all solution or not? we found that for HT and EHT metering, actually smart metering is not required. So we are doing it through our AMR. We have now done 100% AMR, and we are doing it through that. For LT single three-phase, smart metering is very much required because there are lot of issues of tampering, bypassing, underload, and all such issues which can get corrected and through the continuous data from the smart metering, and that also the network supports that, because these are mostly in good network areas, the industries and the commercial establishments. For LT single phase, there are two parts. Three parts basically. One is those consumers who are consuming more than 400 units is one part, which needs smart metering, because we need to also have a monitoring, and we can save a lot of billing and cost. At the same time, there is a lot of discipline and governance and enforcement can be brought in. However, those in remote areas, do they need smart metering, or we can continue with OCR is what we have decided, that we'll go with OCR first and we'll complete the more than 400 first, and then we'll go for smart. Another big chunk is the lift irrigation, which is very common in places like Odisha and other places, even in the hinterland of the country. For lift irrigation, actually, we have decided that we'll go for a new technology, which is the Bluetooth metering. And the Bluetooth metering, we have done a lot of study, and we have seen that these are those units which are far flung into the paddy fields, where either you have standing crops or you have waterlogged throughout the year, and it is not accessible. So nobody was going to take those meter readings. So now what we have done is we have installed Bluetooth meter readings. Smart meter is not possible there because you don't get the network over there. So we have installed Bluetooth metering, and what we are doing now, we are taking the readings through drones. This is also a very innovative project where we have got a lot of awards also. Recently in the CII, we have won an award. This nobody had thought that even drones can be used for taking the meter readings for inaccessible consumers. So the drones we are using for that also, the hexacopter drones, they have a very limited time of flying. So that makes it a hurdle. So we have now designed a drone, co-designed drone which glides, and it cannot come down. So the meter has to have the capacity to send the readings up to a height of 50 meters. And it flies over the 50 meters. It captures the meter readings while the flight is passing through the meters. So this is again something which we have discovered, that smart meter cannot give a solution to that type of remote inaccessible meters which are there. Then on the collection side, the collection was mainly in Odisha, it is done still through a door-to-door collection. And door-to-door has its own issues of connivance, of other aspects, because he's the only person meeting the consumer. So we have now brought a collection app, which actually takes care of all the issues, all the data is provided in that, and through the data, it also validates. It also has the artificial intelligence to validate the payment which is coming, and it then ensures that the collection is done and the receipt is given on the spot itself while the consumer is visiting that. In addition, we have launched an app which we call My Tata Power app, where the consumer can pay directly, and today in the world after the COVID, people have become more tech savvy and digital savvy. So even rural people are paying through the Tata Power app, and getting their can view their bills and can then. Another thing is that what we have thought, that to improve the billing and collection, we have to have a different viewpoint for urban and different viewpoint for rural, because till now rural was every discom does this, that they do not give much importance to the rural population, and there is a thought underlying in any discom that these people are not paying, they are not big consumers, so why do we even care for giving them a better reliability or better performance? But actually we have seen it's the other way now. If we can give a better performance, if we can stand beside them, resolve their problems, they are very good payers. So what we have done is another very innovative concept. We have linked the PDS system, which is the public distribution system, with our customer care, and we call it Anubhav Kendra, which is the experience center, where it is because we have seen that all consumers must come to the PDS once in a month in a rural setup, and that is the where we can get access them. We can try to resolve their problems, because there are many problems for which people are not paying, or not giving access. There are metering problems. There are collection problems. There are some billing errors which are there. So we are resolving that, standing in their place when they are visiting the PDS system, the ration shops, and we are resolving these problems. So these are actually some new things which we have done, and we have found very good result. Our billing efficiency have gone beyond, almost it has crossed 90%. Our collection coverage was, when we took over, it was only 40%. Now we have increased it to almost 70%. So 40% of the consumers could be reached. That was the scenario. And 40% was provisional billing. So now we have corrected it. The AT&C loss has largely got improved. So these are some of the things which we have done, which I think can give a lot of benefits to any other discom also in the similar setup. Thank you.
Thank you so much. As we all know that the consumer are the main important stakeholder, and it is so nice that you are taking care of the consumer, especially agriculture consumer. And once you develop a confidence, and then definitely they will pay, and which you are feeling also. So we all know that technology are really going to help us for improving the problems which existing discoms are facing. So the next speaker, Mr. Giresh Murali, is General Manager, Software and Solution, Siemens Limited. So sir, what kind of solutions you are going to propose for developing and improving the distribution sector?
Yes, sure. First of all, thank you very much for giving us this opportunity to be on this panel in the August company of distinguished dignitaries here. Siemens Grid Software, where we come from, we have 1,300 control centers working across the globe currently, SCADA, DMS, SCADA, EMS. We have 200 plus MDM installations and connecting about 100 million plus smart meters. We have grid simulation software. Many of you must have heard PSSE and PSS SynCal, which is catering to something like 70% of power flows through the networks designed using our software. So we have very significant involvement in the technology aspects across the globe. So based on our experience, what we are doing in other countries, there are three main challenges that are emerging for utilities. The main challenge is the net zero. I mean, if you look at India also, we are looking at 2070 when we want to be carbon neutral. It is a very steep target. We have very fast proliferation of DERs, which is posing real serious challenge for how the grids are to be monitored and operated or managed, and increase digitalization. So digitalization, on the one hand, it provides a lot of opportunities to leverage the technology, but it also opens up the networks for cybersecurity related aspects. So we have to keep that in mind. What we see is that the DRs are going to increase something like 7 times by 2030. The EV charging, the EVs are going to increase something like 5 times by 2025. And the trends what we see globally are coming in India also. India is not far behind. So here we have serious challenge. The grid is going to be completely pushed beyond the limits. And we have to see the technology, how we want to use it. In India, we are using the technology, of course. RDSS is promoting SCADA DMS, deployment of 250 million smart meters and etc. So we are adopting the technology in a big way. But what we want to say is that we have to go a little beyond this. Simple deploying the technology is absolutely fine, but let's go beyond this and let's break the operations, the grid planning, grid operation and grid maintenance, these three separate silos. We have to break them and ensure that the data flows across these three silos. If we do that, the usage of technology can really improve the operation of the network and grid in a significant way. Just to give an example, if we interface the MDM with the OMS of a SCADA ADMS, a lot of outages data, especially coming from the meters where they are not getting the power, can flow into the OMS system, and the reaction by the operating staff will be much faster and more accurate. That will improve obviously, it has the very positive impact on the SIFI, SID and all those parameters, plus it will also improve it will reduce the losses and it will provide good quality service to the customers. Another example that comes to my mind is being deployed in one utility in Austria, where they are interfacing the SynCal, PSSC SynCal, which is the network planning software, with the SCADA data and the meter data. So that way, what they're trying to do is that the network modeling is always up to date as per the existing network. So that helps in identifying the operational problems, that helps in identifying the anomalies very quickly, and it improves the overall operation of the network. So in nutshell, I mean, I don't want to take too much time here because everybody is hungry, even I'm hungry right now. So what I'm trying to say is leverage the technology, interface, interconnect, and allow the data to flow through. That can actually improve the operations significantly. I mean, we had two examples here. Wagmare sir mentioned about MTMC, which is a classical example of how we can use different solutions and interconnect them and actually derive wealth of data, wealth of information from this. Another example is Tata Power Delhi, TPDDL, which you mentioned that it is a single digit, their losses are under single digit. Why it is so? Because they have leveraged the technology in a very, very effective manner. And that is what we want to say. Thank you very much.
Thank you so much. So I'll not take much time, but let me introduce where I represent. I represent as a Director General National Power Training Institute, which is the apex body of Ministry of Power for providing training and capacity building. So we have 11 centers across India, and we have trained more than 4 lakh engineers, and we provide induction training, specialized training, and certification also. So whatever are the mandates given by the government of India, like in cybersecurity is mandated to have all transmission people to get certification in cybersecurity. So we are the only authorized agency, and I'm really very happy and thankful to Wagmare ji that he has supported, and a lot of engineers got certification from Maharashtra because they are really pioneer. So we provide certification in cybersecurity. We provide load dispatch certification also. So and nobody can sit in the SLDC centers without the certification. And also we are the nodal agency for implementing training and capacity building in the distribution sector. So I look forward whenever you want training and capacity building, which are not getting due recognition in India, but please understand, without the training and capacity building, the implementation of any technology is not going to achieve 100%. Thank you so much. I really would like to thank the organizers for putting and giving this opportunity, and I really would like to thank all the distinguished panelists of this panel, which is very importantly combined as a transmission and distribution panel. Thank you so much. Thank you.
So thank you all of you on the dais here. Let me invite Mr. Pankaj Kulshrestha here on the dais. He is the Executive Director in Uttarakhand Jal Vidyut Nigam Limited, and request him to hand over the speaker mementos to all the speakers. This was a combined panel of distribution and transmission, rather lengthy panel, and I know some of them could not get adequate opportunity to articulate their thoughts. To start with, the first memento for Mr. Dinesh Wagmare, our session chair, program chair as well. He does not need any introduction now. Thank you so much, sir. Next memento for Shri K. Verma, Managing Director of Jharkhand Urja Sancharan Nigam Limited. I request Mr. Kulshrestha to hand over another memento for Mr. T. Jagat Reddy, Director Transmission Corporation of Telangana. And I also request Mr. Kulshrestha to hand over one memento for Subhash Kelkar from Rameles Group. turning on the right side of the stage, the next memento for Mr. Ganesh Shankar Mishra, Managing Director, Madhya Pradesh Madhya Kshetra Vitaran Nigam Limited. In fact, I would request Wagmare sir also to join the photo up. I just forgot, memento to be jointly given by Mr. Wagmare and Mr. Kulshreshtha both. I request next memento for Bhaskar Sarkar, CEO of Tata Power Northern Odisha Distribution. Girish Murle, General Manager, Software Solution Siemens Limited. Girish Murle. We have been joined by Dr. Ravi Gupta also, the Editor-in-Chief of Elets Technomedia. And the last memento for our excellent session moderator, Dr. Tripta Thakur, DG, National Power Training Institute. So with this, we break for lunch now. One group photograph, customary, a very old custom in Elets conferences, a group photo opportunity.